writing the equation of a line in slope-intercept form, given 2 points, and then we'll look at how do I model this with a word problem. So in this example, we're given 2 points, and we want to write the equation of a line. We just looked at graphs to write the equation of the line. Now we're looking at points. So earlier, we found how to used the slope formula to find slope. So we know how to do that, which is our first step to determine the slope. So we know how to find the slope for our equation. The second thing we need to do is calculate the y-intercept. Now that is something we haven't done yet, so make sure you pay close attention on how to do that. And then the last thing is just to write the equation, because once we have our slope and our slope-intercept, we just put them together to write the equation like we did for the examples with the graph. So let's start with step 1, which is finding slope. We have 2 points. I'll just, as always, call the first 1.1, second 1.2, and use my equation right here. So -1 minus 8, 5 minus -4. Minus a negative is positive. So that gives me -9 divided by 9, which is -1. So my m is -1. I don't know why I didn't write negative. So that's step 1. Step 2 is to find my y-intercept. Now it says to use the slope in any point and the slope-intercept form, which we said is y equals mx plus b, to calculate y-intercept. Well, if I use the slope, that's my m, and if I use any point, that's my y and my x, that will just leave me with b, and that's an equation. That I know how to solve. The question is, any point. Well, where do I get a point for x and y? Well, they gave me 2. So when it says any point, it's referring to any of the points they give you. So here are 2 points they give me. I can use either of these points. I'm going to go with the first one. It's smaller numbers. I don't know. It looks good. Let's go with that one. So we will say, we already know m is -1. We're going to let x equal -4, and we're going to let y equal 8. We're going to plug that into our equation. I should probably rewrite the equation just so we have it here. Y equals mx plus b. And we're just simplifying to get that b is equal to 4. And now I know that b is equal to 4. I also know that m is equal to -1. And that's all I need is m and b. So now I can do step 3. -m, which is -1 times x, -x, plus b. And I'm done. So what might this look like in a word problem? It's actually not that different from when we were doing word problems with multi-step equations. We actually did a few of these when we did multi-step equations. We just didn't know that those equations were technically slope-intercept form. So we have Teresa. Teresa has a piggy bank, and she has $73 in her piggy bank. She plans to purchase some Pokemon cards, which cost $2.25 each. She plans to save $34.75 to purchase another toy. At most, how many Pokemon cards can she, not he, she, purchase? And we're going to write an equation to solve this problem. I'm going to start by identifying our variable. I'm going to say let P be the number of Pokemon cards purchased. And then I'm going to highlight some important information. We have the $73 that she has total, and the $2.25 per card, and then the amount she wants to save for the other toy. And I'm pretty visual, so I like to start with like a somewhat visual, a visualization. When I can draw a picture, it's helpful. This is not like a geometry type draw a picture thing, but I can visualize this a little bit. If I think about a piggy bank, and so we know there's $73 in the piggy bank, and that piggy bank has two different pieces of things that we're trying to deal with, right? We have the Pokemon cards here, and then we have the other toy. So this is our piggy bank amount that we have, and there are two things we're trying to purchase with it. We're trying to purchase our Pokemon cards and our other toy. What the other toy is, I don't know, but we want to purchase these two things. We do know the price of our other toy. We know that this is $34.75. It's the Pokemon one that we don't know. That's our unknown, because we don't know how many that we want to purchase. But we do know the cost of each one. So if we purchase one, it'll be $2.25. If we purchase two, it'll be $4.50, and so on. So we do know we're multiplying the cost of each ticket or card by the number of cards. And that is our equation. And you may notice that this is actually y equals mx plus b, because the mx part is our rate of change. This is what's changing. The cards, cost of the cards is what's changing. We're going to save this amount here no matter what. It's not going to change. That's the constant value. The thing that's changing is our Pokemon cards, and it's changing by the same amount each time, the $2.25. And now we're just going to solve this problem to figure out how many cards can Teresa save, or can Teresa purchase, and still get the other toy that she is wanting to get. And the first thing we do is subtract the $34.75 from both sides. And then we can divide both sides by the $2.25, giving us that Teresa can purchase 17 Pokemon cards if she would like to spend all of her money. And that is slope-intercept form.